Hello friends, welcome back to Tech Easy YouTube channel. Friends, in today's video we are going to discuss what is CIA, AAA and what is SIG security. So basically this video will be going to a theoretical video. Okay, so here we will learn the basic concepts of security and how it maps into the Kubernetes security. Okay, so let's start. So here we are mainly going to cover CIA, AAA and SIG security. Okay, so first of all, if you have the IT background, then you already know what is CIA and what is AAA. So basically CIA, C stands for the confidentiality and I stand for integrity and A stands for availability. Okay, so CIA and AAA both work together. So basically CIA you can think like outcome, AAA is the actually how it's doing. Okay, so it means in Kubernetes security control, if we talk about AAA, then first A is for authentication, second A is for authorization and third one is for auditing or accounting. Like authentication, in authentication we ask basic question, who are you basically? Okay, and after verifying the identity, we go into the authorization stage, where we define what you can do, and at accounting or auditing phase, we maintain the record of everything, like who is doing what, and we will do what when any mishappening will occur or any disaster will occur, to maintain the availability of the system. Okay, so when we go into depth, so here like we can think authentication is maintaining the confidentiality. Okay, so for this in Kubernetes we have to maintain the APIs authentications. Okay, for that we have to implement the single sign-on YDC IAM federation, like our identity and access management federation. We have to create the SS tokens. Okay, we have to also do the STIR verifications. Okay, so after that we will go at second phase, that is secret protection. Like here we will protect our secrets or our data too. Okay, by using TMS encryption, at rest or sealed secret, external secrets operator, or by integrating with the some vault provider. Okay, so like Terraform vault, HashiCorp vault, we can integrate, or any other vault provider, like there are multiple vault providers present. Okay, so also here we will also maintain the image and supply chain identity. We can like use cosine signatures, city store, Polyco, Covariance, SLSA. Okay, and for maintaining the workload identity, we can use the IRSA if you are using EKS, if you are using GK workload, or then we can use the GK workload identity, and if you are in Microsoft environment, then of course we can use the Azure AD. Although we can integrate Azure AD with any of the Kubernetes cluster. Okay, either it's on premise or it's on cloud. Okay, and second main of our triad is the to maintain the integrity. What we do, we do the authorizations. Okay, so that we have rollback access control, where we always prefer to use the least privilege method to maintain the complete cluster wise roles or single roles. Also we need to control the role binding and namespace isolations. And second here important thing is admission control. Here we can use the OPA gatekeepers, keyword no. Okay, validation admission policies, port security admission, like all these things we can do here. And we can also maintain the runtime policy enforcement by using platform, AppArmor, SLinux, Gvisor or Kata containers. Also in addition to that, we have to maintain the supply chain integrity. Like we need to ensure that our images do not become already compromised. By maintaining immutable images, we have to also validate our software bomb. Okay, what is S bomb? So basically software bill of material, like what software we are going to use in our environment, what are the approved software list. Okay, and here we can also do the policy based deployment and trusted registry. You can use the trusted registry or private registry. Okay, for that, and at last there is also we have to implement the network segmentation. So here all these things we can't skip. In enterprise, if we are doing that, then either by using any tool we have to maintain all these all on the avoidable things. Okay, so in enterprise we use the network policy, we use the network segmentation like using VLAN, VLAN, okay, extended VLANs like this. And we have to also implement the zero trust on east-west traffic. Okay, by using some external firewall tooling or by using some software-based firewalls. It's on organization based on their requirement. They can choose the best one, but they can't skip that. Okay, because each layer is very important. We'll further also discuss the security model. So there we will discuss each layer in detail. So at last, third one is to maintain the availability. We have to set up the accountability or accounting and auditing tool. Okay, so here we will for audit and detection, we can use the Kubernetes audit logs. If you have implemented the fan code, then you can use that. Runtime detection, EBD. If you have implemented the EDPF based CIM, container network, CNI, container network interface. Okay, so then we can use their observability. Also, SIM integration is not skippable here. We have tried to use any of the SIM tool, but here we have to use at least one tool, and we have to centrally manage all those logs. Okay, on the basis of there we can just create the alerts. Okay, and also can monitor the complete environment centrally. Also, we have to implement the threat and detection like intrusion detection system, intrusion prevention system, anomaly detection, and runtime behavior analytics. Okay, so for resiliency and recovery, we have to either we can set up the complete backup of complete environment, or we can choose go with the complete taking the backup of some critical data like TCP backups and also most data backups. Okay, by using many tools, and many tools are present. If we are using the it's based on completely our infrastructure. Okay, like how we have created our infrastructure. Like we can, as you know, we can create Kubernetes cluster by using bare metal nodes and virtual nodes. Virtual nodes may be also based on KVM, based on ESXi, based on any other hypervisors. Okay, like we can use the OpenStack based virtualization. Okay, so based on that, all those requirements we can go with the best tools, but at least we have to use the one single tool listed here, one single tool to maintain the each points listed here. Okay, so for our availability protection, we can use the resources quota, limit range, SPA, VPA, and port disruption budget. And for DDoS and reliability control, we can use the API rate limiting, web application firewall, ingress protection, cluster auto scaling, and service mesh retrace circuit breakers. Okay, so if you talk about the modern stack, then here we can do the code by using the tree SAS analysis, and then in build stage we will sign by using cosine and verify response, and in registry we basically do the verification by okay, here we can use the Kubernetes maintaining the emissions controls like things. Okay, and here to verify OPA. Okay, also here we can at deployment stage we can enforce the ASA and rollback access control. Okay, this is least privilege. Okay, at runtime stage we for detection we can use the FICO, EVA, PB, or any hardware or software based firewalls too. And for observability, we can integrate to maintain the audit. We can use the SIEM tools. Okay, that will basically create a record of everything. Okay, for recovery purpose, we can say backup and recovery. For recovery, we can restore our backups that will are created when well or DDoS or any other tools. Like if we are using VM environment, then we can take the complete node backup or snapshot backup, and we can restore that. It will contain the all the things like complete node environment, complete applications and Kubernetes environment too. So you can think like triple is secure access and CI is the outcome of secure access. Okay. So authentication protects confidentiality, authorization protects integrity, auditing protects the availability and recovery. Okay. You can think like that fundamentally. Okay. So one important thing is the SIG-Security model. So basically SIG-Security model is a layered model where it's basically 4 layers that define the threat model from Kubernetes: secure design principle, admission control behavior, secrets and credentials of security, and supply chain security directions. So also it controls the CVE handling and the mitigation. So that is this, and this is specifically for Kubernetes and CNCF endorsed. Okay. So key points here is that this is going to define how Kubernetes should fail safely, not just how it runs safely. Okay. So if an interview, if anyone is asking like what is SIG-Security, then you can tell that like Kubernetes security controls are aligned with the SIG-Security threat model and layered defense principle. Okay. So basically, you can think like that. Kubernetes security is not just a single feature. Okay, so it's a layered approach. It's a layered approach to maintain and secure the Kubernetes environment. So Kubernetes, I tell you, it's like 4 layers. First one is infrastructure layer, then second one is cluster layer, third one is workload layer, and fourth one is supply chain. Okay, so at layer 1, we have to maintain the infrastructure security that comes with like OS and hardware. And might be if you are taking infrastructure as a service, you are going to add cloud provider, you are taking infrastructure as a service, or you can go to the platform as a service. Then you don't have to take care of the infrastructure if you go with platform as a service. But if you go with the infrastructure as a service, then you have to infrastructure security is your responsibility. Although cloud provider will maintain the underlying infrastructure that is found in those same infrastructure. Okay, like hardware and data center security is responsibility of the cloud provider, and OS and above that is responsibility on your side. Okay. So it starts from basically with the OS and hardware layer. It includes the physical DC or cloud host security, OS hardening based on the CIS and kernel tuning, and here secure boot and permanent trust, hits and hits on nodes, basically host intrusion prevention system, host intrusion detection system are nodes. Okay, this encryption, mode isolation, NTP and time integrity, network segmentation, central logging, all which comes under the infrastructure security. So in BFSI, I have experienced them mostly in issue. It starts from the OS. Okay, like OS hardening as per CIS. Okay, and root access traceability and patch and vulnerability management. Okay, you can think like that no hardened OS, then no compliant Kubernetes cluster. Okay, so layer 2 is the cluster security. Here it's come basically at control plane plus core API layer. Okay, so this layer protects Kubernetes itself. If cluster security fails, then there might be some unauthorized API access can be granted, privilege escalation may happen, rollback access control, and maybe token theft can happen, etc. data can be compromised. So we have to maintain the following controls here. Like we have to maintain API server authentication and authorization, rollback access control, like who can do what, and admission controllers, etc. encryption at rest, audit logging, and we have to maintain the certificate life cycle. We can use the QCA or any other tools for rotating the certificate on the time. So if you are using website, then it's always very like you are doing the certificate renewal after certain interval, like after 1 year or few 15 months. Okay, so these are very important. Okay, and also third layer is the to maintain the workload security, like pods, containers, runtime. Okay, this is where applications actually run. Like here we are talking about the pods, okay, containers and runtime environment. Okay, so here we will provide the like common threads here is privileged containers. Like we have created a privileged containers that have node access to. Okay, so in that case, if that container will be compromised, then complete other containers can be, there is a risk might happen, complete containers of that or complete cluster can be compromised, because attacker might use those containers to access the nodes, and after accessing the node, attacker can access the complete cluster. Okay, so about that. So there might be lateral movements inside cluster, as I told you. Might first get access of node, and then after the second node, and then third node, then complete cluster. And namespace is took over. Attacker might get the complete namespace access, and might be cause of security due to security leakage may be happen here. So part control we can take here. Like we can first of all maintain the port security standards as per our organization and application nature. Okay, and we have to maintain the security context hardening. We have to check the Linux capabilities, and we have to minimize those. Okay, at our containers and pod level. So runtime security, we can use the Falco of eBPF. Okay, and we have to use the read-only root file system. So here, next security control is even trusted application must be run with the minimum privilege. Okay, it's the same as the least privilege you have to give. Okay, when you use the rollback access control, then every user should be granted the minimum or least privileges to perform their duty. And the same containers or pods should be given the minimum privilege. Okay. So supply chain security. So to maintain the supply chain security, that is the most complex thing. Okay. So here we have to take control of all the, like from the code levels analysis, okay, to image analysis and CI/CD pipe, secure CI/CD pipeline, and also to take care of the artifacts. We have to secure the artifacts. So here, like if you have the malicious base images and image type costing, compromised shell pipelines, or unsigned or tempered image, then whole security can be compromised. Okay, so this is the most important, because here we have to maintain the complete supply chain security. So for that, what controls are just we can take? We can use our trusted private registry. Here we have to also first we have to scan the codes, and then we have to also maintain the image vulnerability. If there is any vulnerability, then we have to patch that, and we have to always scan every image. Okay, we have to also check the signatures and we have to verify the hashes of all those images, and we have to take the branch tracking. We have to also take care of the admission time enforcement by using the admission controllers. So like in banking totally right, like if you trust every image, then our cluster is or your cluster is already compromised. Okay, so this is the most important thing we have to take care of. So these all four layers matters together. It's not just like you have maintained a security at infrastructure layer and you have not maintained the security at the Kubernetes cluster layer or pod level or application layer or code level. So these all things we have to basically comes together to maintain the complete security. Okay, like if your hardware will compromise, like if your server in data center or in cloud environment is self compromised, then how you can protect the underlying things that are basically run on that. Okay, so we have to maintain the security at each layer. Okay, so basically we have to validate cluster security footprint. Like before adding tools, we must validate the baseline. Okay, high level validation question is each API server or authentication is enforced, each anonymous access is disabled, each etcd is encrypted at rest, each our data is encrypted at rest and in travel or in transit. Okay, each our namespaces are isolated, all the default permissive are restricted. Okay, so our mindset should be the like validation before hardening prevents the false security. We have to validate first and then harden. Okay, as per your environment, as per your requirement. Okay, like everything is not true for every environment. Okay, we can't maintain make each of these points happen in every environment, but we have to first review your environment, and you have to make layers in your environment, and then after you have to brainstorming with the different teams. Okay, then you have to implement the security layer by layer, okay, as per your workload and application nature and environment. Okay, so in upcoming video we'll go inside the labs. Okay, so we'll discuss about like admission networks or security enforcement, attack, network isolation, and live attack and defense demos. Okay, so that's it for this video. So thanks for watching the video till the end. See you in next video.